This video is on how to work with a discrete random variable, which is the first part of Chapter 6, Section 1. First of all, what is a random variable? It is just a variable that produces a numerical outcome from a chance process. So basically anything that produces a number. So in regards to people, it could be the number of cars that, let's say, a family owns. It could be the number of siblings that someone has. Both of those would be discrete. Or it could be someone's weight, that they weigh 176.28 pounds, or their height or something like that. But anything that produces a number. Now, a discrete random variable has a countable number of outcomes. So many times it's the integers. It is something like I said, the number of siblings that someone has. It could be 0, 1, 2, 3, or 4. Or it could be, so the number of AP classes that someone takes, that could be 0, 1, 2, 3, 4, and so forth. But the key thing is there's gaps between the values. Most of the times it's integers, but it's not always. It can be something like shoe size. So it could be 8, 8.5, 9, 9.5. That sort of thing. Continuous random variable can take any value in an interval, so it can contain decimals. So it could, someone's weight could be, 142.687 pounds, or their height's 187.268 inches, or let's say the amount of time they sleep at a night could be 7.2641 hours. It can take any value in an interval. So the most popular form of continuous random variables that we've worked with is a normal curve, but we're also going to work with a uniform distribution. And so let me show you what a discrete random variable in essence is going to look like. So a discrete random variable is going to be expressed like this. It's going to have whatever the outcomes are. So in this case, it's the number of car crashes in a given week. It could be 0, 1, 2, 3, or 4 for this particular place. And then it lists the probability of each of these. So it has a probability model. So when you see a problem like this, you're going to think, this is a discrete random variable problem, and you'll think about what I'm fixing to explain here. Now, first of all, the probabilities have to add up to 1. Something has to happen. So when you add up 0, 1, 2, and 3, they add up to 97.97. So this has to be 0.03 right there. And so anyway, and what this is saying is basically there in 50% of weeks, 0 crashes occur. In 20% of week, 1 crashes occur. And so in 16% of weeks, 2 crashes occur. And so basically, another way of looking at this would be just a bunch of zeros, 1, 2s, 3s, and 4s laid out, where half of the numbers are zeros, and 20% of them are 1, and 16% are 2, and so forth. Now, and you could be asked, a very simple question such as, what's the probability if you randomly select a week that there'll be more than 2 crashes, let's say? So more than 2. And so you would just say, well, more than 2, that's 3 or 4. And so that's 0.11 plus 0.03. And so that's 0.14, or 4. There's a 14% chance of that happening. Which, by the way, that is a different thing than x is greater than or equal to 2. Greater than or equal to 2, you would include 2. So that would be 0.16 plus 0.11 plus 0.03. And so that is equal to 0.3, or 30%. So in discrete random variables, greater than is different from greater than or equal to. But in continuous random variables, it's not going to be that way. The continuous random variables, as we'll discuss, is greater than something is the same thing as greater than or equal to, or less than something, same thing as less than or equal to. And so we have this problem. So what is the probability, given that there's more than 1 crash in a week, so given that x is greater than 1, what is the probability to be more than 3, that x is greater than 3? So there's our notation from the last chapter. The probability that a randomly selected value will be greater than 3, given that it's greater than 1. Well, you remember our formula. It's the probability of both of those things. X is greater than 3 and x is greater than 1 over the probability of the second thing. Probability x is greater than 1. But what's the easier way of saying that something is bigger than 3 and it's bigger than 1? It's just that the probability of x is greater than 3. Okay? And so over the probability x is greater than 1. And so in this chapter, the conditional probabilities, the probability of one thing given another, is just going to be the probability of that over the probability of that. Well, the probability that x is greater than 3 is just 0.03. The probability that x is greater than 1, well, that is going to be that it's 2, 3, or 4, and so that adds up to 0.3, and so that divided by that is 0.1. And so that's how you handle the conditional problems. Now, to make a histogram, so, you would just, in essence, it would end up looking something like this. And so, you would just draw a bar to each of the percent values. So 0 goes up to 50%, and 1 goes up to 20%, and 2 goes up to 16%, 3 to 11. And so you just put bars to whatever their probability is. Make sure to label and scale your axis. And so, by the way, so for this one, you would note that it's centered around 1. The spread can be described by the range of 4, and the shape, it appears to be right skewed. And of course, we're going to find the mean and the standard deviation to describe the center and spread. So that's just your standard cussing. But first of all, and sort of the main heart of what I want to show here is how do you find the mean and standard deviation? Well, if you look on your formula sheet, there's 2 relevant formulas here for this. And it's the next 2 formulas on the formula sheet. It's there. The expected value, as we call it, or the mean, is the sum of every x value times its probability. And then this is going to be the variance, which is the square of the standard deviation. And we'll use that in a minute. So our mean, otherwise known as expected value, is going to be equal to the sum of every x times every probability. So you can just show that right on the table up here. You can just say, well, I want to find the mean. So you just say 0 times that. You just multiply each of these. That times that is 0. 1 times that is 0.2. 2 times that is 0.32. 3 times that is 0.33. 4 times that is 0.12. And then, so we have all these values, and you just add them up. You add them up. That's what that sigma means, that summation notation. And so that, in fact, is equal to 0.97, and that is the mean. That is our average. If we were to look at a large number of weeks, we're expecting that to be the average number of crashes. So that would be a description of center. We could find the median of this, by the way, but that's more of a later issue. It would be 0. But anyway, but now let's find the standard deviation. Okay, so our formula here off of our formula sheet is the variance, the square of the standard deviation, is the sum of every x minus the mean squared times the probability. So what I'm going to do is I'm going to take every x value, the 0, 1, 2, 3, and 4, subtract the mean of 0.97, then square it, and then multiply it by p. It's rather tedious, but it's just relatively simple operations. So let's take every x value. We'll take 0 minus the mean of 0.97, square it, and then multiply it by its probability of 0.5. And so when we do that, we get, I believe that this is 0.47045. And then do it with 1. 1 minus 0.97 squared times its probability of 0.2. And so when you do that, you get 0.00018. And then 2 minus 0.97 squared times its probability of 0.16. And so that is 0.1697, and then 3 minus 0.97 squared times its probability of 0.11. And so that would be 0.4533. And then lastly, I'll take 4. So 4 minus 0.97 squared times its probability of 0.03. And so that is going to be 0.2754. When you add all of these up, you would get the variance. So the sum is equal to our variance. And so that, in fact, is equal to 1.3691. And we would take the square root of that to find our standard deviation. And so that is 1.17009 approximately. That is the average amount that our points are varying from the middle. Certainly very tedious. To do that with your calculator, now to show your work, you would need to at least show a couple of these calculations here, and then you can put a little ... saying that pattern continues. But you have to show, if you're asked to show your work on the mean, you could just show your work just like I did on the table and show that those numbers are added. To show your work for the standard deviation, show a couple of these cells and put ... You don't have to put all of them, especially if there's something like 10 numbers or something, because that'd be really very tedious. But you can use your calculator in this manner. So So what we'll do is to do this with your calculator is I'm going to enter my x values and my probabilities into lists. So if I go stat and edit, and they're already there, but I'm going to clear them out, just pretend that they're not there. So I'm going to just put all the x values, 0, 1, 2, 3, and 4 in list 1, and then in list 2 put the probabilities, 0.5 and 0.2 and 0.16 and 0.11 and 0.03. Okay, I believe I did that right. So now that I've entered them in a list, I'm going to do one variable stats. So there's my x's and there's my probabilities of each of the values of x. So to do one variable stats, I do stat, calculate, one variable stats, put list 1 there, and then in the frequency list, every other time the rest of the year, we leave this blank or we put a 1 there. This is the only time all year we hit second and the 2 button to put list 2 there, and I do calculate, and it tells me there's the mean and there's the standard deviation. That is certainly a lot easier than if you've got one that has like 10 values especially. But you can use that to check your work. Lastly, and most importantly, how would you describe these things in context? You know, doing this stuff by hand is not that critical. It is important you understand how to do it. But what's more important is you're able to state the meaning of the mean and standard deviation in context. And this is the way, in essence, you would say it. Our mean is 0.97. What that is saying is, if we were to look at a large number of weeks, we predict there will be 0.97 crashes on average per week. Don't say that, hey, if we looked at 1 week, we're expecting 0.97, or we're expecting 1 crash. Do not round that number. Do not round it. Report it its exact value. Certainly, if it has a number of decimal places, at least put, a few decimal places, 2 or 3. But that is stating the meaning. You have to say it as a long-term issue. If we looked at a large number of trials, that's important. Same thing with the standard deviation. It's the average amount. The points vary from the middle, but in context, if we looked at a large number of weeks, we predict that the number of crashes will vary from the middle, from the mean of 0.97, by an average of 1.17009 on average. So it's the average amount the points vary from the middle. Thank you, and we'll continue on with continuous random variables, which is the next part of section 6.1 in our next video. Hope you have a wonderful day.